The students have been given a cup with 3 dozen grains of rice. They find the mass of the rice to be 0.58 grams. This means that the rice has a mass of 0.19 grams per dozen grains of rice. To check this, the students are now going to find the mass of 6 dozen grains of rice. The mass is 1.24 grams, which gives a mass of 0.21 grams per dozen grains of rice. Allowing for experimental error, the two calculations are the same. Now the students find the mass of a sample of an unknown amount. The mass is 1.94 grams.
So, using the conversion factor that the mass is 0.21 grams per dozen grains of rice, I want you to calculate how many grains of rice are in the sample of rice that has a mass of 1.94 grams. Did you get it? You should have figured out that there are approximately 9 dozen grains of rice in this sample. Remember, when you work a conversion problem, you let the units guide you. So, we put 0.21 grams on bottom and 1 dozen grains of rice on top. We multiply and get 9.2 dozen grains of rice. Let's peek back in on the students to check our answer.
The students are counting the grains of rice in the sample. They have divided the sample into piles with a dozen grains of rice in each. They have 1, 2, 3, 4, 5, 6, 7, 8, 9 dozen, with 2 grains of rice left over.
Excellent. The students were able to use mass to count the number of grains of rice in the sample. They could count the number of grains of rice in this bag without even opening the bag. Are you thinking what I'm thinking? Perhaps we can calculate the number of atoms in our sample of copper, the number of formula units in our sample of salt, and the number of molecules in our sample of water without having to actually see them and count them. Of course we can. Chemists are the smartest of people, after all. And they have come up with a system for counting atoms. Pretty impressive. Think about the experiment.